Hello everyone, my name is Ivan. Together with my colleagues Riccardo, Antonino and Fabio, we would like to present you our vision on the secure software development in the era of fluid, multi-party open software and services. In the last decade, software development changed dramatically. Development became fast-paced. Nowadays, several versions of the product might appear in a single day. Democratized. Development teams work independently, and they have limited central oversight. Hence, much less control. And last but not least, developers focus only on differentiating features and reuse the existing functionality of open source projects and open frameworks. All these trends dramatically transform the very nature of software development. To capture this evolution, we introduced the notion of MOS, or multi-party open software and services. MOS reflects the nature of nowadays software that changes constantly, and these changes are often performed by people from different organizations. In the era of MOS, software developers themselves have a dual role. In fact, they are not developers, they are MOS prosumers, as on one hand, they develop their own code, and on the other hand, MOS prosumers consume the code from other projects, such as open source projects. The MOS era pushes security to evolve. In this respect, we identify the following two challenges. Challenge 1. Internal software is not trusted any longer, and therefore we have both internal and external sources of insecurity. Hence, on top of having secure coding skills for the own code, it's very important that we consider security of architecture and of the new features imported from dependencies. Challenge 2. Often security is understood as some periodic quality gates, like monthly security certification of a product. However, in the MOS era, several releases appear every single day. The rigid security gates simply cannot cope with such fluid and fast-paced software development nature. Instead, security could adopt the concept of lightweight and intelligent screening tests. To better explain the concept, let me mirror the situation in medicine. Imagine the situation with a widespread disease, such as COVID. The computer tomography is very effective, but simply too expensive to test every person. Instead, lightweight and relatively cheap PCR tests are used to pre-screen people and only then do expensive CT procedure for the pre-selected people to better diagnose them. Now my colleagues will introduce you to our vision of how security could catch up on the design, code, build, and test steps of the DevOps process.
So if we look at the architectural design of a software application, the current best practices can be summarized as putting a group of knowledgeable stakeholders in a room where the high-level model of the system is sketched and a risk and security analysis is performed manually. Because of the two challenges mentioned in the previous slide, however, this paradigm is showing its limitations. For instance, as the code is refactored regularly, also the results of the risk analysis quickly become obsolete. And at the same time, the sudden inclusion in a software project of external components and frameworks might introduce security flows. For instance, if the dependency comes with its own management interface, for instance, then that could lead to the violation of some policies or principles that are being enforced in the system, like, for instance, a full mediation principle. So if we revisit the picture that I gave you at the beginning of this slide of the bunch of experts in a room sketching a diagram and analyzing the security issues of said diagram, we see that we need to provide more automation in two directions. First, bottom up. The design models should easily be derived from the code base, and also top down, there should be a form of traceability between the analysis results that are done on the model and the corresponding code. so that the impact of code changes could be easily reassessed.
The lack of centralized oversight over the development process has a major consequence in the way quality and security are evaluated. There is a definite shift from process-based security assurance to an approach that is more artifact-centric, and particularly more code-centric, the source code being the primary artifact of any project. A consequence of the combination of many independent projects, each following their own life cycle and practices, is a continuous stream of security-relevant events observable in multiple source code repositories, controlled or influenced by independent parties. A few thoughts based on these premises. First, we currently have very limited visibility into these security-relevant events originating in third-party repositories. And this makes it difficult to evaluate the security posture of the building blocks of our projects, and even worse, to react to certain events in an effective and timely manner, such as when a vulnerability is introduced or even when a fix to a vulnerability is committed, maybe without an explicit advisory. Second, we need to complement full-blown code analysis with more lightweight techniques, capable of reasoning about increments, that is, commits, as opposed to full code trees. And lastly, the large amount of code available out there is certainly a challenge to the scalability of security assurance techniques, but it's also a great opportunity to apply machine learning to source code analysis. For example, to investigate the application of methods stemming from natural language processing or the use of specialized graph neural networks.
We are now at the crossroad of changes. Things change all the time. Changed by us, by introducing new commits, or by others. New vulnerabilities are discovered in our dependencies. How do we certify that the final application is secure? Industry standards ask for the entire application to be ready, and we use qualitative risk metrics based on expert assessment of the whole system. This is too late, too slow, too brittle. As in John Donne, no code is an island entire of itself, right? Every software is a piece of the continent, a part of the main. So we need to introduce the notion of delta certification. We should be able to leverage on what we certified before, so that we only certify the changes that we introduce. And what about the entire forest of libraries on which we base our code? We need to have new indicators that provide quantitative measures to the entire process, so that we can see the evolution of our risk profile throughout our continuous integration and continuous development pipeline. So let me summarize the whole story of the brave new future in which we are all consumers and producers of software as a Lego bricks that change dramatically. The security expert should be able to have a bird's eye view of their security posture. This means that we should have risk indicators that are dynamically updated and reflect the current deployed architecture, the services and libraries that are actually there. The most prosumers should be able to get a gut feeling of the impact of changes, either created by them or imposed on them. Which architectural flows are introduced, which commits may be security relevant, even if they aren't marked as security. Given the insane number of commits and changes in the continuous development integration process, the huge number of direct and the indirect dependencies to monitor, we need something different than traditional testing and verification. We need a screening test. A screening measure, like in healthcare, is inexpensive, but it's quick, and it must be able to scale to the whole healthy population. Then, on the one that didn't pass, we can do diagnostic tests, such as verification, full application testing, and so on. This is the only way out in the new world. And so, let me finish the presentation by saying if you have ideas, want to know more details, or catch up with our activities, please check out our website assuremoss.eu. And don't forget to check out also our technical leverage talk in the main track. Thank you for your attention.